as I go through it. Page 100. Let's try it again. There you go. Doesn't like a blank page. Okay, so test checklist. So what I'm going to do is I'm going to have accuracy here. Circle it. And then kind of go off of it, right? So when you have a standard unit, and appropriate scale, right? That's one way, like we would say that a measurement is accurate if we can show that we're using a standard unit, so a meter, a centimeter, kilometer, mile. We're not using like a body part or like a branch that you found on the ground, right? You're actually you're looking for that. We also know it as how close the measurement is to the target. How close the measurement is to the target. You should be able to repeat. Measurement, right? We're talking measurement here. So technically, if you're using an appropriate scale and you're using the standard unit, you should be able to tell anyone, hey, you want to measure the field for me, please? And they should get very close to what you got. Okay. It can be affected, so I'll just start here and then do the bubble. Can be affected by damaged device, and I hope you know that that means measuring device, and improper use would also qualify as, like if I ever ask you, hey, what happened here? How come the measurement isn't accurate? Well, maybe the device has been damaged or the person hasn't been using it properly. Okay. Anything else for accuracy? I think we're good there. And then we have precision. So I'll go a little lower, maybe right about here. It's basically the limitation of the measuring device. Every device has some kind of limitation. At some point it rounds. It can't go any further, right? So, and obviously some are more precise than others. So arrowhead goes towards it, right? And we go over here. Smaller increments equals greater precision. I'll give you a very simple example right under it. So smaller increments, greater precision. So if we have like two short rulers here, and if this thing goes 2, 4, 6, and you had another ruler right next to it, it also has 2, 4, 6. But we're going to add a little marker in between values. And remember, these markings are done by the factory, right? So they're like, they tell you exactly where halfway is. This has a precision of 2. This has a precision of 1. So this one would win. Okay? Just a cheesy example there. So precision is there. Over here on the left, I will say 3 ways to get precision. And I will circle things in a little later. I want to see how this goes. A picture. You're looking for words such as markings. That's one in particular that you want to look out for. And a number. So if it's 3.721 grams, we focus on that last digit. So it's 0.001 gram. That's my precision. Okay. So what I'm going to do here is I'm going to circle the whole thing. And just make an arrow go out of precision towards that big circle or big cloud. Uncertainty. It's essentially the margin of error. Caused by the limitation of the measuring device. Greater precision equals smaller uncertainty. And of course, uncertainty is equal half the precision. There. Combine uncertainties, or combined uncertainty, we'll say, right? Always add all uncertainties. And I'll do an example, right? So kilograms, 5.1 kilograms, and 1.27 kilograms. Right? So if you had them like that, I will allow you to take the precision and the uncertainty right next to it like that. Right? And then just make a line like that. Yeah. Up. Is that good? Okay. So if we add this up, zoom in. Which part? This part? Okay. I'll pause a little bit and then I'll zoom in, okay? And let's see here. 7, 3, 8. And then you kind of ignore this and just focus on the uncertainties, right? So we're going to go plus or minus like this and just add these all up. And it just happens to be 0.555 again. It's not always going to be 0.555, so don't think that that's what it is, right? This is measurement plus or minus uncertainty. That's what we just did. Okay. That's what we just did there. And you get your min and your max out of that. I want to leave some room for tolerance. I'm just going to leave this as is. So let's make this just a big cloud. Keep things inside the fence there. We're good. I'm going to do tolerance right next. You can zoom out a little bit for that, I think. Tolerance. And this is where we might run out of room, but I'll try my best. It's the range of acceptable values. That's our first, we need to have a definition. I will do the 4 ways to state like right on along the side here. Four ways is the max, min. I will box that in because that's one format. You can have the max plus 0 minus the tolerance. You can have the min minus 0 plus tolerance. I will zoom into it in a bit if you're squinting. And then you have the nominal plus or minus 1/2 the tolerance. I will go from here and just say that tolerance is equal to the max minus the min. In a nutshell, like if you want to calculate the value, that's how you would do it. And I will do this here, arrow. I'll just say that nominal is our target value, what we're aiming for. And obviously this isn't everything, but I think it does a pretty good job at summarizing everything we've done. You should have a section that says like, if I ask you for an example in a certain scenario, you should be able to write, well, if it's too small, then this will happen. If it's too large, then this will happen. Or if it's too little or too much, right? Like what will happen in either case, you got to be able to justify. That's basically what I'm looking for when I want you to apply the concept of tolerance to a certain scenario. In terms of review, I will give you, just because I have it, I will give you 2 old ACs that I haven't used, I guess, this time around. And I will post the keys to this online. So if you want to review and get ready, 2 more goes at it, it's up to you, right?